Poisson distribution. Poisson distribution is used when you're measuring the number of times an event will occur in a given opportunity. And the example that I gave you here is the number of scratches in a car paint, the number of mosquito bite on a person, the number of computer crashes in a day. So we're looking for the average number of events that will occur. And the average number of events that will occur is what we denoted as lambda here. And the formula that we're going to use is Poisson.disk. And then I'll ask you for three variables, the x, the mean, and the cumulative. And then for the mean and variance calculation and standard deviation calculation is very simple. Your mean equals to lambda, which is your average number of events. Same for the variance, it's just lambda. And then your standard deviation is your square root lambda. And how you know the difference between Poisson distribution and binomial distribution is that for Poisson distribution, you're given an average number of events that will occur. So you're given a number. While for binomial distribution, you're given a probability, which is your pi. So binomial distribution, you have your pi with your probability. For Poisson distribution, you're given an average number of events that will occur. So you're given a number. So number for Poisson, probability for binomial. So we're going to go for example 3 right now. Example 3, over a period of 3 months during the year, an airline's rate of involuntary denied boarding was 0.88 per 10,000 passenger. Complete part A through part C. Part A, what is the probability that in the next 10,000 passenger, there will be no one involuntary denied boarding? So what we're looking for in part A is we're looking for probability of x equals to 0. We're looking at the probability that no one will be denied boarding. So therefore, we're looking at the probability of x equals to 0. And when you're reading the question, how do you know this is Poisson distribution? It's because when you look at the number 0.88 per 10,000 passenger, that number is an average number. So the number of events that will occur. So therefore, we know this is Poisson distributions. In example 2, what we had was 53%. So that 53% is the percentage. That means it's a probability. That is your pi. So that's how you know this is binomial distribution, because you're given a percentage. So that's how you know that in example 2, this is a binomial distribution, is because you're given a probability. Probability is equal to 53%. That's your pi. While for example 3, what we had was that with 0.88 passenger will be denied boarding. So that's your lambda. That's your average number of events that will occur. So that's how you know whether this is a Poisson distribution or binomial distribution. You look at the number that is given to you. Is it giving you pi or is it giving you lambda? In this case, we're given lambda here. So once we understand that concept, then we can solve part A. In part A, what we're solving for is probability of x equals to 0. So before we solve for part A in Excel, we need to first calculate the mean and variance and standard deviations. And then the mean is basically your lambda. Lambda is 0.88, so there's no calculation there. So mean is just lambda, and lambda is 0.88, so there's no calculation there. Same for variance. Variance is your lambda, so therefore it's just 0.88. And then your standard deviation is the square root of your variance, so that's why we square root the lambda. So we square root the variance. So we put equal SQRT, and we square root the 0.88, and you're going to get 0.938. So that's how we calculate the mean, variance, and standard deviations. Once we have the mean, variance, and standard deviations, then we can use the Poisson.disk formula to calculate the probability of x equals to 0. So we use equal Poisson.disk, and then we click on the f of x. For the x is your x equals to 0, so we put 0, and then your mean is lambda. Lambda is 0.88, and then your cumulative will be false, because we're looking at the probability of x exactly equals to 0. So that's why we're looking for x equal to a specific value, so that's why we put false for cumulative. And then once we plug that into Excel, you're going to get 0.41478. That's part A. Part B, what we're looking for is the probability that in the next 10,000 passenger, there will be at least one person denied boarding. We're looking for at least one person will be denied boarding, so probability of x is greater than or equal to 1. So from the diagram perspective, what we have is we have x going from 0 all the way to 10,000. So we could have 0 people being denied boarding all the way to 10,000 people denied boarding, because we're serving 10,000 people. And we know that all the possible outcome has to add up to 100%. So what we know is that from x equals to 0 all the way to x equals to 10,000, when we add up these probability, it has to add up to 100%. And in this question, what we're solving for is x is greater than or equal to 1. And to find out the probability of x is greater than or equal to 1, so to find out the probability to the right of x equals to 1, what we need to do is we need to take the 100%, and then we subtract the opposite. And the opposite is basically your x equals to 0. So that's why in part B, in order for us to find the probability of x is greater than or equal to 1, what we do is we take the 100%, the whole area, minus the opposite, which is the probability of x equals to 0. And that will give you the purple area here, which is the probability of x is greater than or equal to 1. So if you understand this diagram, then plugging it into Excel should be straightforward. Since we have already calculated the probability of x equals to 0, then what we do is we take the 100% equal 1 minus the probability of x equals to 0, and that will give you the 0.58522, and that's part B. Part C, what we're looking for is the probability that in the next 10,000 passenger, there will be at least 2 people denied boarding. So what we're looking at is the probability of x is greater than or equal to 2. So again, same concept, we draw the diagram. We have all the possible outcome from x equals to 0 all the way to x equals to 10,000. So these are all the possible outcome. And what we're looking for is x is greater than or equal to 2. So we're looking for the pink area. So what we do is we take the 100%, and then we subtract the opposite. The opposite of x is greater than or equal to 2 is x is less than or equal to 1. And that's the opposite. So what we need to find out is the probability of x is less than or equal to 1. And then we take 100% and we minus the blue area, and that will give you the pink area. That's what you need to understand. So for part C, to calculate the probability of x is greater than or equal to 2, we take the 100% minus the opposite, which is the probability of x is less than or equal to 1. So we're going to find out the probability of x is less than or equal to 1 first. And we use the formula Poisson.this, so equal Poisson.this. And then we click on the f of x. We'll ask you for 3 variables. The x is less than or equal to 1. That's what we're looking for. So we put x equals to 1. And then the mean is your lambda, so 0.88. And then our cumulative is true. The reason cumulative is true is because we're looking for the cumulative probability of x from the very left side all the way to x equals to 1. So that's why we put true here. So once we calculated that, then we're going to get the probability is 0.7797%. Once we have the probability of x is less than or equal to 1, then we can take 100%, and then we can minus the probability of x is less than or equal to 1, and that will give you the probability of x is greater than or equal to 2. So what we do is we take the 100%, so we put the equal 1 minus what we have calculated, the 77%, and that will give you the 0.22%. And that's the probability of x is greater than or equal to 2. And that's part C. So when you're dealing with these questions, the key concept that you need to know is draw a timeline. You need to understand the timeline. Whenever you're looking for x is greater than or equal to a certain number, what you need to understand is that how Excel works is that Excel only gives you the probability to the left. So that's why if you want to find out the probability to the right, what you need to do is take the 100% minus the probability to the left, and that will give you the probability to the right. That's the concept that you need to understand with these probability distributions. And that's example 3.